So our next step in rational functions is to look at what actually happens where the denominator equals 0, right? We already said that's out of the domain, but what exactly does the graph look like when there's a number that we cannot use? Okay, so there are actually two things that can happen. So let's ask that question. What happens where the denominator is equal to 0? Okay, so for example, f of x is equal to x plus 2 divided by x squared minus 4. Okay, this is a rational function because it is one polynomial over another polynomial, so great. We know it's going to look, something like that rational function, but what exactly does it look like? So we can tell that we should probably factor. So x plus 2 divided by, this is that difference of squares factoring, x plus 2 and x minus 2. Okay, right here is where we should find the domain, because we have two things in that denominator that we need to take care of. So x plus 2 cannot equal 0, so x cannot equal negative 2, and x minus 2 can't equal 0, so x cannot equal 2, right? So we know those are the two numbers that cannot be in the domain. However, we do know that if we have the same factor on the top and the bottom, x plus 2 and x plus 2, the whole factor, then we can reduce. So we're going to reduce this function to 1 over x minus 2. Okay, so this is the simplified version of the thing. So we have two things in that are happening in the domain. At one place, x cannot equal negative 2, and at a different place, x cannot equal 2. So let's graph this function and take a look at what's happening. Okay. So take a moment and look at this graph, and you may want to graph that original problem that I gave you as well. Notice that I have to use parentheses around my numerator and denominator to tell it what thing is on the top and the bottom. Your calculator may have little fractions and then you don't have to, but if it's like mine, you'll have to put parentheses in there, or otherwise your graph will never turn out correctly. All right, so in this graph, notice that one thing is happening at x equals 2, right? There's that vertical asymptote that we started talking about, but there is not a vertical asymptote at x equals negative 2, right? There isn't an asymptote there. You can't see anything going on. However, one last place to look. Look in this table, okay? At negative 2, there is an error, okay? There is no point at negative 2. It says error for the y value. And then at 2, there is also an error at, I don't know what that little thing that's following me around is, but see at 2, there's also an error, and that's the vertical asymptote there. So let's take a minute and draw this lovely thing. And I think when you're doing this initial homework for this week of section 5.4, I think you're going to want to use your calculator and graph some of these because until you get used to them, you won't really understand what's happening unless you see them. Okay, so we had that vertical asymptote there at 2, and then we had something happening over there. So I'll just keep on this color. And then we had the graph looked like this. It still looked pretty much the same as the original. And then the graph over here looked like this. It's just moved over. Okay, but we did see at negative 2 that there was an error. So on our graph, even though you couldn't see it on my calculator, we want to put, in our graph, we're going to put an open circle there. Okay, so you can see that at x equals 2, That is this one. Okay, so there's two things happening. A vertical asymptote is where the denominator equals 0, okay, but it can't be canceled out. Right? And then just there isn't a vertical asymptote over here because notice that what we did was we crossed out this and this, right? We divided out the x plus 2, so that -2, that one is what's called a hole. It's called a removable because we did remove it, removable discontinuity. Also known as a hole. And that is where the denominator is equal to 0, but it can be canceled with a term from the numerator. So I would write all of that down. You're going to get used to looking for these things, but it can be a little intense, a little confusing at first. Okay?